Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to calculate Gibbs free energy changes and predicting spontaneity from your enthalpy change and your entropy change. So here's an example of a reaction. So we have a carbon tetrachloride gas breaking down into carbon, graphite, and chlorine gas. And we're given the enthalpy change 95.7 kilojoules and the entropy change 142.2 joules per Kelvin. And the first question is calculate the delta G at 25 degrees. Is the reaction spontaneous? So to calculate the delta G, the Gibbs free energy, we're going to use this equation. Delta G is equal to delta H minus T delta S. So all we need to do is plug in the values we're given, plug in the temperature. Temperature should be Kelvin. So we'll have to add 25 degrees. We'll have to add 275 to that to get 298 Kelvin. And so when we plug everything in, the delta H is going to be 95.7 kilojoules minus, and then we have the temperature times delta S. So that's going to be 298 times delta S, which is 142.2 joules per Kelvin. So this is Kelvin. Kelvin cancels out, gives us joules. We have kilojoules here. We're going to have to change this to joules. So here, this is going to be 95,700 joules minus whatever that is. It's going to be 42,375. So 42,375, 42,375 joules. And now we subtract that, and we should get, it's going to be 53.3. So this is going to be 53.3. Did I just write that right? Times 10 to the third joules. So it's positive. So we've calculated our Gibbs free energy. Our Gibbs free energy is positive, so that tells us that it is not spontaneous. So in order for a reaction to be spontaneous, it has to have a negative change in the Gibbs free energy. So the next thing we do is for part B, if it's not spontaneous, what temperature, if any, is it going to be spontaneous? So looking at the equation here, this is positive. So delta H, there's nothing we're going to do to delta H to make it this negative. So we got to look at this, our enthalpy change. Our enthalpy change is positive, so that means that we could make this more negative by increasing the temperature. So if we increase the temperature enough, we can make this part more negative to overcome the positive enthalpy change, and then that would bring us negative. So what we want to do is find the minimum temperature at which above which you would have the reaction become spontaneous. So what we need to do is set delta G to 0. And so then what we're going to do is we're going to solve for the temperature. So we put in the values. So we put in 90. We'll put in this again. So we have 95,700 joules of energy minus T and then times, what did we have? 142. So 142.2 joules per Kelvin. And so what we need to do is now we solve for the temperature in Kelvin. So we're going to bring this over to the side here. So this is going to be negative 95,700 joules is equal to negative T times 142.2 joules per Kelvin. We're going to divide both sides by negative 142.2 joules per Kelvin, negative 142.2 joules per Kelvin. Joules cancels out and we get Kelvin, and the answer we get for that is going to be 673 Kelvin. So we get T is equal to 673 Kelvin. This is the temperature above which this reaction becomes spontaneous, because above this temperature is when the Gibbs free energy would become negative. Okay, what about the next problem? Okay, so for the next problem we have this reaction here, C2H4 plus hydrogen gas gives you C2H6 gas. And we're given the enthalpy change of a negative 137.5 kilojoules and the entropy change of negative 120.5 joules per Kelvin. So again, the first question is asking you calculate the delta G and tell us if it's spontaneous. So we are going to calculate the delta G using the equation of delta G equals delta H minus T delta S. And so we're going to plug in our delta H. Delta H is negative 137.5 kilojoules. We'll convert that to joules. So it's going to be 137,500 joules. That's going to be negative, minus, and then the temperature again is 25 degrees. So again, 25 degrees Celsius is 298 Kelvin. Multiply that by the delta S, which is negative 120.5 joules per Kelvin. So the Kelvin cancels out. We've got joules. And then when we calculate that out, it's going to be plus, what was that? 35,909 joules. So this plus this. So this is going to be negative 137,500 joules plus this. Add those together and we get, this is going to give us 101,600. So it's going to be negative 101,600 joules. And so this is the Gibbs free energy. It's negative. So that tells us it is going to be spontaneous. And so the next question is, does the delta G become more negative or more positive as temperature increases? So looking in here, so we're looking at temperature and we're looking at what happens here. So we got a negative and a negative, that's going to become positive. So as temperature increases, this is going to become more and more positive, and it's going to cancel out more and more of the negative. So as this increases, as this part increases, then the overall delta G is going to increase and become more positive. So it's going to be less negative, more positive. So that's the answer to that question. I hope this helped you a lot. I hope you enjoyed this video. If you enjoy my videos, please like, share, subscribe, hit the notification bell, put a comment in the comment section, and thanks for joining me. I'll see you next time.